The thing I like about, one of the things I like about this day is the fact that we make the faculty get up and give talks instead of having the faculty make their grad students get up and give talks. So it's a far more sporting event. And with that, I'd like to introduce André van der Hoek, who's the chair of the Informatics department and a member of the ISR faculty.
So yeah, imagine the department chair surprised when Dick said, "I'm retiring." But the good news is that there's a faculty slot. We get to bring in somebody else, and things will continue. We'll continue to expand. So, especially because he promises he'll be involved in research, so we're going to hold him to that. I also want to welcome everybody. I especially see a number of our alumni. I think that's just fabulous, and a bunch of the local industry, same way of fabulous. What we're doing here today is sharing with you sometimes research we're very far along, sometimes research we're kind of just starting with. My talk in this particular case is the variety of this is what we're just starting with. The students will have demos and posters on this later on. And any and all feedback that you can give them, whether it's positive or that's just absolutely don't ever try to do that kind of project, is appreciated. So with that, I want to talk a little bit about search in the crowd and next generation software tools. The original title was Topic Search in the Crowd, but 15 minutes turned to be a little bit too short to try to stick in 3 different topics. So we stuck in 2, and the other ones you'll have to see in the lab. So we're researchers, right? And we're meant to remember things from longer than 5 years ago. And this is not something we always see at our conferences. But it's certainly something that I really like to practice. So the Interlisp environment is one of the very first software development environments, in this case programming environment, that came into existence. Not the very first one, but certainly it was there. And if you go back to this paper, there's actually quite a bit of insight into it, which eventually made its way into what we're actually doing right now. What I like the most, though, is that this was the only picture that was in that paper. Everything was text. And it sure looks like the guy's wearing some sort of biohazard suit trying to work with the computer as opposed to, or it's a character from Star Wars. That's the alternative interpretation that I have there. But it was interesting because they did a lot of stuff that we see in the editors that we use today. And the ideas were there already. Now, of course, this was long, long ago. Then came something called VI. In Emacs, for those of you who remember programming in that, or those of you who still love programming in that, because I know some people exist. This is actually not the version that I used, because this one already has color highlighting, which mine clearly did not. I'm not that old, but yeah, mine did not, because the monitors were blue or black with green little lettering. But you started seeing some support for what you were doing, right? Bracket matching, outlining the text, and those kinds of things, making your life a little bit easier. Of course, then came this. That most of you probably are familiar with at this point, Eclipse. This is, it's over 10 years old now, which is interesting because that's exactly where my talk is going. There's a lot of functionality. It was an extensible system. You could plug in more functionality yet. And this has become sort of the de facto standard in various other sorts of variants that are available right now for how you are to do your software development. And there's a lot more tooling that's around this as well, right? So it's integrated with your build system. It's integrated with your testing system, if you so wish. Integrated with your CM system. Now we're seeing actually some interesting environments emerging. So I find now a really, really interesting time. When I look at research, there's always these sort of waves where everybody gets on a certain topic, and then after a while peters out, and then it's very quiet for a while, and then that topic sort of re-emerges. And for me, software environments and how we program and how we develop is coming back as such a topic. So we're looking here at Xcode, building apps for iPads and iPhones and those kinds of things. And this actually has a really interesting characteristic because you're actually starting to see the flow of the app in here, right? So it's starting to give you more of what you are actually building in the environment as you're working on. And if we push that a little bit further, this is a system called Lighttable, which, for those of you who are Kickstarter followers, was one of the largest Kickstarters related to software development. So it's a live programming environment. The idea is whatever you program here immediately has an effect on what you see. And so you're programming, and it immediately is running your program. it's quite a bit different from what we're used to, 10 years ago, 20 years ago, 30 years ago. To some degree, we had I had 4 different windows open. Here I typed, here I made, and here I ran. And all of that is now sort of integrated in this particular environment. It's still experimental, but it's coming. And they're providing support for a number of different languages. So of course, as a researcher, I'm supposed to look way back, such as to the Lisp environment, but I'm also supposed to look forward, as in what might actually be coming next. And so what I want to talk about is 2 projects that we're involved in at this particular time. One that we call social technical code search, and one that we call crowdsourcing. And so let me talk about each one of those. Each has about 7 slides, and then I wrap it up at the end there. So social technical code search. Well, how do we do our code search now? Well, the first thing we need to think about is that there's a vast amount of code actually available on the internet right now. We all know this, and it has really changed how we do our programming. Whereas in the past, I might have walked to my colleague, or just try to find the manual, remember that, or I might just try to code and try and try and try. Nowadays, a lot of programmers have changed their habits. They're typing a query into Google, they're typing a query into StackOverflow, they're typing queries into all sorts of different venues that are available, where I can maybe get an example, or on StackOverflow I could get somebody who says, well, here's how you do it, or here's the particular pitfall. And so search has become a real integral part of the programming experience. There's papers looking at programmers and saying how much time do they spend just programming versus searching, and you see that search over the years has gone up. Now what's interesting to me, of course, is that, well, how well does this search actually work? And so we recently wrote a grant proposal, and we said, let's take a random query here, and let's submit it to Google. So secure key generation in Java, essentially. And so these are the first 10 results that come back from Google. And if we look at those, there's a subpage of a longer tutorial that only shows a small portion of the overall code of how to generate the digital signature. Not quite enough. The second one is a subpage in a longer tutorial for key tool. Unrelated. Okay? This was actually not useful to me. The Java doc page for the class key generator, which only lists the methods. Right? It doesn't tell me anything about how to actually use it. And so we can go through all of these 10 and actually kind of not get the answer. And so if we then go off and we say, okay, let's issue this into StackOverflow, then you get a set of answers that actually all are still of the short variety and don't give us the answer. If you go to Olo, it gives you 12 different pieces of code. The first one is written by an undergrad somewhere. And do I really trust that undergrad having written that right piece of code? Right? It's a piece of code that was never used. And that sort of gets to the point that I want to get to is all this code is available and all this code is searchable, but I don't get much of the context around that code. I don't get much told about the history of that code. What is it about that code that I might be using in making the decision whether I want to reuse this, yes or no. So if I look at code search, there's a couple of requirements for me. The first one is I really want to see real code and real use. Right? I want to see code that Roy has written rather than the undergrad as part of their actual project in school. Somehow I'm going to trust that code a little bit more. Roy's smiling. He might know more about his actual coding. But from an outsider, I might actually, yeah, exactly. 12 years ago, last line of code you wrote, I still trust that line more than the undergrad. But generally, I want to search for real code and real use, right? Actual examples of how people have used this in actual systems. I want to be able to better understand the context surrounding the results of this search. Who's authored it? What language is it? What version is it? Does it actually pass all of its test cases? Are there even test cases associated with it? I want to know the history of that code in terms of how it's been adopted and adapted, right? Have people actually taken this code and used it already before? That would be a real useful bit of information for me. How much time did they spend adapting it to their local environment, to their actual system? Also would be a real useful piece of information. And I should be able to work with these search results directly in the development environment. I kind of shouldn't have to jump out onto a browser and then figure out a way to bring it back. So what is context for us, right? I hinted at it a little bit already, but there are 6 classes of information that we've talked about that not only do we think are useful for a developer to get when they're searching for code, or actually to even search explicitly on, but also that we think we are able to get by making small extensions to the development environment of everybody who's programming. So there's various ways in which to get this kind of information to feed into the search engine so that we can get to it when we're searching. So static information is very simple: which project, which authors, which source language, which operating system, which version, all that kind of information. But then there's also derived information, and this one is actually kind of important. These code churn, past bugginess, number of authors, test coverage are all indicators, have been shown in the literature, indicators of the quality of the code. So the more code churn there is, the buggier the code tends to be. The past bugginess, how buggy it's been in the past, tends to be an indicator of how many bugs you might encounter in the future. So these are implicit kind of quality measures that I can associate with this code. Okay, and how do I can get these by actually looking, for instance, at the versioning archive, or I can look at the build system or the test system. The code history, projects that adopted the code and how the code was adapted. So if I took that code and I made a set of changes, but if 30 people took that code and made the same set of changes, that's useful, right? I probably need to not just pick up that code, but I probably need to pick up those changes as well. How much time did it actually take to make that adaptation? And then also, the social environment. Are the folks falling into my set of colleagues, right? Can I scope my search to just the people in my organization? Can I scope the search to my friends? Because I'm going to trust them perhaps a little bit more than a random person on the street. And are there recommendations associated with this code? And then finally, social feedback. Is there a reputation? So this is going back more to the StackOverflow model. Is there a reputation of the person who developed this code? Can we vote them up and down? And are there tags associated with that code that help me describe what it is? And there's various ways in which to actually get this kind of information. Sometimes I need a little plugin in your environment that just monitors your searches and says, hey, yes, you copied it. So +1 for the number of people who copied it. In other cases, I can actually do a lot just mining the archives that exist of the various development projects. So with that, we're actually also looking at how do you search differently, right? Google, you type in a term and that's it. Well, suppose you type in a term and you actually get an interface that looks like this, where you say Java key generation secure, and it's inside the circle. And for me, I also get additional tags associated with this particular search, associated in other pieces of code. And what if I could just drag this tag inside here and drag that tag to the second circle? In that particular case, I can change my search queries, and I get actually a very nice representation of relevant or related kinds of queries that I might issue to refine my results. And of course, I probably want to see multiple code snippets at the same time, right, with some of the meta information attached to it. So that's one design that we're playing with. Another design that we're playing with is this one, where we actually want to look more at the people. So thinking about the social network. Are these people that fall within my social network? And the code snippets, and then seeing how much of that they've actually authored, so that I can actually say, yes, I trust that, that's somebody I know. I'm gonna look at their code a little bit more. And then having this little widget over here, which we call the code orb, attached to each of these code snippets. And this widget actually goes from green to red. And it's the one that looks at the derived information of past bugginess, code churn, number of developers, number of test cases, all those kinds of things. And then uses a simple little metric that says, well, if there's lots of developers, that tends to be a sign of more riskiness. So we're going to color this a little bit more red. If there's more code churn, or if there's little code churn and the code has actually been used a lot, we're going to color that little metric green. And so by attaching this to each of these code snippets, I get sort of a color wheel that could be green, that could be more red, that could be more somewhere in between, where I can actually look at these metrics and make an assessment of that code just by glancing at that and be able to select a little bit more quickly. So we've actually started playing with this, and with just one little dimension of meta information at this point, which are tags. And so we're asking, how can we actually tag these pieces of code, these little code snippets? And so what we're doing actually is we're actually running LDA, the little text mining algorithm, over this code that suggests a set of tags that automatically get posted. I can, of course, change these tags. If I actually change these tags, the updated tags get posted. But that gets posted, and I or somebody else could actually search on those tags later on. So the overhead of actually associating tags with this piece of code is very low. It happens automatically. I can adjust it if I want to. But I'm not explicitly going, I'm now checking in something that has these following properties and da-da-da-da-da-da. It's a very lightweight mechanism, which is exactly the point. And then on the other side, I could actually type in my code, I could say, I want to look at user Jeffy82 looking for AES, and I get a little list here of all the code snippets that match that, and I can just walk up and down and get the code snippets in detail that I can then, with just pressing this spacebar, I can put that back in my environment and I can work with it. So this is a way of actually overlaying a tag sort of approach to the code bases that exist. And for that, we don't need to build a separate repository of all the code in the world. We can just build indexes into that repository with the tags over that. So this is an ongoing project. Lee Marty is working on that. He'll have a little demo of this. He'll have a poster of this. And we believe that there's a lot to be done in this particular space to really help you get to relevant code snippets that you can use quickly. The other project, crowdsourcing, is a little bit more far out there. Okay, so bear that in mind. And the motivation is twofold. The first motivation is this one. What you're looking at is a system called, I think most of you will know, Folded. Folded is a protein folding game, in essence. And it's a crowdsourced game, which means that there's a central server where they say, well, here's a particular fold that we're trying to figure out. Does this look like it? Does that look like it? Does it look like it? So it sends it to all these different users around the world. And they get an interface like this that says, well, you know, there's a little problem over here. Can you find a way to fix it? And the user tinkers for a little bit, spends a few seconds, folds it slightly differently, and says, I think this is better. Okay? Very, very simple interactions. But it's very, very powerful. Because you get so many people involved, they've actually been able to solve, within like 15 days, a particular protein folding problem that had taken scientists about 10 years. So the power of the crowd, and in particular the power of redundancy, sending the same problem to multiple kind of folks, and getting lots and lots of input, turned out to be very, very fascinating in terms of doing things very, very fast. And the interesting thing also is that these are really tiny microtasks, right? This is not somebody sits here and goes, I'm going to spend a couple of hours doing that. They take the image, they read the instructions, they go, let's make it this way. I think that's better, and they submit it, and they're done. So very small time slices of being involved, but a very powerful mechanism. So this one is called Duolingo. It's a translation engine based on the same kind of principle. So what we have is here a little couple of examples of text. You are supposed to translate it. You send it. You're done with that little micro task. Nothing more than that. But everybody contributing to this set of micro tasks contributes to the overall translation that's happening in the overall body of knowledge of this language. And anybody who's bought Ticketmaster tickets and any of those other ones, and you've done the reCAPTCHAs, you know, you get the little funky word that looks a little squiggly, and you're typing it in. You're actually participating in crowdsourcing. You're participating in taking books, handwritten books, and turning them into text recognition. You're actually participating as a text recognizer, because all that goes back to a digitizing project that actually tries to digitize lots and lots of old books. So that's where a significant portion of those little CAPTCHAs are coming from. So there's a lot of power in actually involving lots of people in lots of small little tasks. Now let's look at the second motivation. What do these all have in common over the past 3 months?
They're richer than we are.
They're richer than we are, correct? They've all been broken into. Right? All their security systems have been broken into. And if you pay attention to the paper right now, many, many, many more cases of that are happening all over the place. So the second motivation is, what if in a time of crisis, okay, just putting the hat on of defense, our defenses are not strong enough and critical software is stolen. So somebody steals, and indeed, actually, I think it was yesterday or the day before, somebody has accessed source code for some particular defense systems. Okay? So suppose it's stolen, or our adversaries act in ways in which we did not anticipate, or succeed in developing new capabilities that eclipse ours, right? So if they have access to our source code, that software that is our cyber defense might not be so strong anymore, because they can read the source code, they can explore all the vulnerabilities. What do you do in that particular case? So the motivation there for me is, well, what if we can mobilize unprecedented number of people to develop new complex software ultra fast, right? So in the same way that we do this protein folding, could we achieve something similar in software engineering, where everybody gets a tiny little micro task, right? Not, here's a task, here's a change that you need to make to the system. No, it's like, write this method, or write this test case, or verify this test case. And underneath, there's a system that continuously sends all these things to everybody. So you break the traditional notion of a development task, and you have to, of course, think very differently about the tools that you're working on. So we're working on a example, and so sort of trying to figure out a way of demonstrating that this might just be possible. We have set the modest goal of, can we crowdsource 500 lines of code? Right, that's the first question. Can we just do 500 lines of code? Kind of like model checking. Can we model check 7 lines of code? And now we can model check millions of lines of code. So hopefully by setting a modest goal, we can sort of get there eventually. And so the environment, I'm not going to go into detail, but allows you to edit a function, write a little test case, reuse, see if there's a method that already fulfills this. And each one of these is just one task that somebody does. It doesn't have to be me, it can be anybody else. And of course, you earn points and all sorts of other kinds of things to have a leadership board and blah, 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 blah. So turning it a little bit into gamification of software development. And our question, of course, is what can we do with this? And particularly, what's the software equivalent of a microtask? How do we deal with design in this way? How to coordinate at massive scale? So what if 10,000 people are all programming these tiny little microtasks? Is that a possibility at all? And we seem to think that we might be able to do it. There's some hurdles, so this is a multi-year project. How to deal with failure? So can we actually deal with failure in terms of running multiple similar tasks to multiple people and then see 3 of them agree out of 4, et cetera, et cetera, et cetera. And so I am just going to go right there and say all of these projects are on display, including additional ones on design, topics in software ecosystems, and one more. And we're in a slightly different building, but somebody will figure out how to get you there. And now I'm supposed to ask for questions. So please.
Actually, you don't have any time for questions.
Oh, that's good. Thank you very much.